knowing what's happening here, I was forced by Gail to present a project which is M365 DSC together with sampler and a DSC release pipeline. Just this accidental audience. Who is using DSC? Okay, who is using DSC in connection with an Entra ID and M365 tenant? Nobody yet. Okay, so this is mainly about two things. One is Microsoft M365 DSC. No, that's the Hilton page. Microsoft 365 DSC. I guess many have heard of you already about this project. It's a fund of resources to manage all kinds of things in Azure, starting from Azure Entra ID groups, access policies, SPO settings, Exchange settings, everything that is important. And the list of resources, as you can see, is extremely long. So if we go for the workload Active Directory, for example, which is now Entra ID, here are a number of resources. Exchange, pretty much the same, or even longer. Intune, SharePoint, Office 365, everything, right? So the question is, how can we configure a Azure tenant not by hand, but by the same principles that have proven pretty well for on-prem scenarios as well? And unfortunately, I have done a similar talk last year, but unfortunately I failed to upload the slides, so the slides are gone. I made some screenshots which are not very much worth, so after all, what I'm presenting by the slides is just the on-prem thing, the old stuff, but the principles are pretty much the same as we have it for the cloud world, right? So I'm not sure how much time I have, and Gail is no longer here. 45 minutes, okay, good. That's hard to fill, actually. Anyway, what we are going to present is based on the work of Gail Kolas, Michael Green, and Steve Morawski. So it's mainly about the release pipeline model white paper. We call it an evergreen white paper because the principles haven't changed. It's still one of the most valuable paper if you want to learn something about automated deployments in a release pipeline with all the control that you need. Then usually we talk about DSC basics, which I will not cover here because I guess you're all experts and know how DSC works in general. What I wanted to emphasize mostly is on this one, right? I'm still using Gail's very old slides. I think they are from Gail. When did you do the slides? 2016? Gail is typing. When did you do the slides? 2016? 2015? Yeah, okay. Yeah. So I think he is now refurbishing the slides, but they are still pretty important. And it's all about what makes a solution a good solution, right? And in all our IT projects, usually one of the main constraint, the main bottleneck that we have is human interaction, human itself, because humans don't always react the same way that they should do, and they may not do the work exactly as documented or required, right? So we want to have a solution that is adaptable, predictable, reliable, lowers the cognitive load to the absolute minimum so that it can be also used by maybe even first-line supporters. And it is removing the single point of failure, the bust factor, the one person that knows everything. So the thing is, if you know how to implement a certain change, usually these changes are done, especially if you come to PowerShell, by the very few people who know PowerShell very well, right? So if you put this knowledge into a release pipeline, then it makes sure the release pipeline even works if this one person is not available, right? Because we have an automated process which always works as expected. Let's move to rather this slide here. Yeah, how can we improve this? So we want to have a solution that is no longer, okay, pointing to the slide is a bit difficult here, too far away. We want to have a solution that is not doing the change or not propagating the change in a manual way. We want to be able to propagate a change also in Azure through a multi-stage release pipeline. So most customers that I'm dealing with are not having just one Azure tenant. They have maybe 10, 15 Azure tenants. And for each Azure tenant, they have also a dev and a test stage. And it's almost impossible to guarantee that the same change is being propagated in a proper way to all these tenants in the same way, right? Usually, after a couple of weeks or months, you see differences in the configurations and things are no longer working as expected because of configuration drift, right? So in an on-prem scenario, we use DSC to exactly mitigate this problem by applying all the configurations using DSC, and now the same thing should be working also with the cloud world. So the thing is, usually we are creating a change, we are documenting the change, which adds a little trust to our change. So with this additional trust, we go to our test environment, we are testing if the change is being implementable there as well, and if the outcome is as expected. So now we have 2 trust bits after we have passed the test environment, and then we move with our full trust in the production environment. And then the question is, are we doing the work in exactly the right way, right? So even if documentation is fine, even if the tests have passed and everything is good, then still we don't know if we are implementing it in the right way. And this brings us to a build and release pipeline, which is creating an artifact. So that's all the idea, that we are creating an artifact in our release pipeline, and exactly the same artifact is being applied in the dev, test, and production tenant. Of course, with differences, because in our production tenant, we definitely have different credentials than in our dev tenant. We have different maybe naming conventions, we have different IP ranges and so on. So this needs to be taken into account, but we are creating one package that goes through all the stages and is being tested there. And let's go straight into a demonstration. So, who has visited or attended the session of Gail about module design, module development, modern module development? Okay, so you guys then know Sampler. Sampler is a module scaffolding solution, actually, but it's very extensible. And we used it here for DSC to adopt the same principles of having a kind of release pipe and a build script on premises, also on my dev machine. And I can create all the artifacts like they will be created in the pipeline, also on my local box. Bigger, of course. So, what is the essence? If you have a DSC solution, what is the essence? What needs to be created? We need MOF files, right? DSC is about MOF files, and these MOF files need to contain all the information that are used to configure the tenant. So, usually a MOF file contains the configuration plus the configuration data. And then the things are getting a bit more complex, because configuration data is usually stored in hash tables in PowerShell, PSD1 files. They are inflexible. The question is then, how can we express differences if we have multiple tenants that are not always the same? And how can we kind of reduce redundancy, meaning that we have a baseline that is applying for all the tenants, and then we have exceptions, then we have maybe different settings per tenant. And this is done by kind of removing the PSD1 files and replacing them by YAML files, right? So all our configuration is stored in YAML files. Like, for example, here we are creating AAD administrative units. And for each workload and each configuration item, we have one YAML file, otherwise the configuration would get too big. It's even in this kind of modern data model, the data pretty quickly gets pretty complicated or complex. So if we, for example, want to disable or enable, or let's say remove a group in a certain tenant, then first of all we have a hierarchy like this. We are starting with our all tenants configuration. So that's the baseline. All the tenants will get exactly the same configuration as defined on that layer. But maybe we want to have some certain group removed in our dev environment because we don't need it. So we go then to the environment-specific container. And in the environment-specific container, we find our workloads. In this kind of presentation, I have only Azure AD and Exchange. Then we find our groups in here. And if I want to remove one of these groups, then I can simply add ensure absent. Okay, so that's my change. I want to remove a group. Usually a change always goes through a pull request and a review process, right? You never commit to main. In my presentation, it's a bit simpler. I can commit it directly. So what we do is we do a minus test group 1, and I commit this single change. And then we are pushing the change to our repository. So what's next? What do you think? What is the next step that is required to make this change getting effective? Rhetorical question, nothing, right? Actually, you can go home. unless the tests are not failing. If the tests are failing, of course, then we are stopping propagating the change. But if we go into our development project, this organization, here's the release pipeline. We see the release pipeline has been automatically started. And what the release pipeline is now doing, it builds the artifacts. Let me increase this. Is the font size okay? Hopefully, yeah. So what we are doing now, we are building the artifacts, the MOF files for all 3 individual environments. So DSC was originally built to configure on-premises nodes, computers. So here we have tenants. So how does this kind of fit together? For each of our tenants, we have an Azure build worker. You can see that here in our project settings. Oh, it's a bit too small. I don't find the menu. In our agent pools, DSC. Agents. So for each stage in the environment, we have one build agent, and that build agent has been assigned a managed identity that has the necessary permission to configure the tenant, right? So that's an important and very sensitive machine. And each build worker gets a capability indicating the environment for which it is configured. Capabilities, and here we have our build environment, which is for that specific machine set to dev. So as soon as the build pipeline starts, we are getting only the information on that machine for the dev environment. We are building the artifacts, the MOF files. And as soon as the MOF files are created, we are applying the configuration to the dev environment. And if the application succeeded, then we are validating the configuration, making sure that everything is as expected, as is defined in the desired state, right? And only if that all happened, we are moving forward to our test environment. Let me zoom out a bit. I think it's either then, yeah, then we are moving forward to the test environment and then to the prod environment. And the nice thing here is this concept is pretty much extensible, because if you start the pipeline manually, you see we have parameters for which environment we want to build. So if we are in a development phase and we want to rapidly test something only on the dev environment, it's very easy to just remove that, and then it's only dev. If we want to, for example, have another quality assurance environment that we need, then it would be pretty easy to do a name QA, and this is then, depends on, you get the idea, right? Depends on dev. Okay, then we would, no, depends on test. Test, and then we would have our production depends on QA. Of course, given that we have a 4th tenant, then we want to deploy the configuration as well. So this is pretty much extensible, completely configurable depending on your deployment scenarios. Okay, so that means after a couple of minutes, I think the pipeline here runs, let me see how long the last run took. It took 40 minutes, right? After the 40 minutes, all the changes defined in the MOF file would be automatically applied. The nice thing now is, if you have everything in a configuration file and you are configuring your tenants based on the DSC configuration, you can always validate if the configuration is still in place. So you don't need to push a new configuration just to get an idea about what's happening. What you can rather do is run the test DSC configuration, or use something like, I hope I get the screenshot. Let's see. Yeah. Or it could look like something like this here, that you have a report that is actually getting you the idea about what is your state of your environment, how many resources are in desired state and how many are not. Because now, as we have a configuration, it's always possible to compare the configuration with what is currently happening in the field, right? So the workloads that we are able to configure are pretty much extensible. So at the moment we have, let me go to our composite resources. So we have composite resources. That's a requirement of this project. I will not dive into composite resources. but it's very easy to extend the project, and at the moment, we can cover all these resources that are configured here. So SharePoint, Security and Compliance Center, Exchange Online, Azure AD, and the list is growing. I know from another customer who is currently adding Teams settings, so that you'll also be able to configure Teams. And this customer is using this configuration in a completely different way because they have about 500-600 contractors that they provide Azure services to, and they want all these 600 tenants to look pretty much the same. So they use this scenario not to configure a scenario like here, dev, test, and prod, but to push the same configuration to all their clients in separate repositories, mainly for Teams. Good. Any questions so far? I mean, this was a very, very quick deep dive to just get you an idea that DSC is not necessarily used to only configure a node, but rather reach out to an external system and configures that, right? So let's have a look into the MOF files to give you an idea about what's happening in the background. If we are looking at one of the MOF files, then usually this is something registry related. Where is the first Azure resource? Here we go. For example, our AAD group, and we have all the group details and one important property, which is managed identity. So that means we are taking the machine's identity and we are connecting with that identity to the respective tenant, doing the changes. Of course, this requires a bunch of permissions, and we have provided also the necessary functions to take the required permissions from M365 DSC and apply it to the managed identity and also update the permissions accordingly. So that's nothing that you have to do manually. And if this is not possible, then another way is to use, unfortunately, it's still required in many areas. How do you show that? The official project. No, let's go to the portal. So, app registrations. So, this is the application that we are using in the backend, LCM M365 dev prod test, depending on the tenant you're working in. And then we are currently transferring this to a new model. Then this is also indicated by the name, M365 DSC LCM cert application. So some workloads still required a certificate-based authentication using the app, and this is done then with this one. So we are also taking care of the certificate distribution for being able to log on with these ones. Unfortunately, because of the font, many things are hidden here. Yeah, right. Then it's working with a self-signed certificate, but can be also switched, of course, to public ones. Good. Any questions, any ideas so far? So, Gail, what do you think? Shall I dive into Datum a bit? Right. So usually, if you work with DSC, you may know that DSC is using a hash table called configuration data at the backend, right? So let me go into some basics. So that's just a normal DSC configuration. Hasn't changed very much since years. It's still the same. And if you want to remove static data in your configuration, you can do this by using configuration data, which is idempotency. It's not so important. This one. What is configuration data, right? It's a big hash table, and the structure of the hash table is in this little yellow box. So we need an all nodes property. Still, DSC is coming from the on-prem world. This is why it's called all nodes. And then we can add as many other keys as we want to. And that's the complexity, right? The hash table pretty quickly grows, and you need some way of kind of separating the data in different areas in different files. And this is, that's the bad example, this is why we need a composition model, right? Gail is smiling because of his old slide. And the composition model doesn't apply anymore, right? So this is still the on-prem composition model. We have a baseline, we have various roles, we have environments, locations. In our case, we only have a baseline, and then we have one layer per tenant at the moment. So this concept is, or this design is never finished. It grows over time, right? So maybe some customers realize that they need on top of the tenant some other abstraction layer, maybe. So, and what we do is, in the on-prem world, if we want to know which kind of software to install, we first get the software assigned to a specific role, maybe even to the baseline, right? And then we go up in the hierarchy, and finally, we can merge all these things together. So if you have a file server and you want to install some reporting services on all file servers, of course, it's defined in the role. If you have one location with some specific requirements, then you define an additional requirement in the location layer, which then gets merged together and applied to the individual nodes, right? So it's pretty much like group policies, right? In group policies, we had also the OU hierarchy, and depending on where you want a group policy to be active, you assign it to the respective OU, and here you just add the respective information to the layer. Pretty much the same. At the end, this is how it looks like. Yeah, that's a little bit deep dive into how a DSC works. So DSC has resources, right? The resources are the things that are actually doing the work. In our case, we have an M365 resource, which is called AAD group. It receives the configuration data and creates a group. That's it. The problem is that the data that we have in our project is usually not compatible with what the resource takes. So we need some layer that takes the data, transforms it into what is required, and then passes it on to the DSC resource. Another requirement is why we need this data model is many DSC resources take only one value, right? So if we want to create 500 groups, then we need to have 500 calls to the resource that is going to create the groups, right? But the YAML model and the DSC resource design is not compatible with each other, so we need to have some kind of for each mechanism, a loop that runs over our config data and then passes the information further, right? And this is why we need something like this, which is a module that contains a bunch of composite resources. And these composite resources do all the translation. The nice thing is for M365, we have a code generator which just generates all these composite resources on the fly, because there are only two flavors. One flavor is that a resource can be available or can be defined only once. It's a so-called single instance resource, or it can be defined multiple times, like, for example, an Active Directory group. So what we do then is we have a file server here. The file server has a role, which is file server, obviously, and this requires us to also have a file called file server. So it's pretty much like a link. If there is a role file server, then we are grabbing the file server YAML file, getting the data from there, and merging it together with what was defined on the node itself. So here, for example, we are creating files and folders on the file server level, but we could create other files and folders on the node level, and all these data then is merged together and then passed to the composite resource. The composite resource does the translation as required and passes it on to the file resource. Good. Getting back to Datum, because actually this is not so important, and let me do a demonstration. So as we have said, a DSC takes a hash table as configuration data. And let me get my prompt. Where is it? Here it is. And what we have here is just a YAML hierarchy. So in our source code, dear recurse, you see we have a bunch of YAML files, and all these YAML files store the data. So the question is, how do we move from a bunch of YAML files to a hash table that DSC understands? And the product that we use there, a solution, is Datum, written by Gail in the back there. And for an easy demonstration, we can just read our YAML files and translate it into a new Datum structure. datum file, datum. So the datum YAML file is kind of the definition file. Here we have defined where are the data, in which paths they are, and how they are merged together. We will have a look later on that one. Okay, and that was not good. And this is what comes back. So here now we have a hash table representation of all the YAML files, and the hash table has exactly the same structure as my folder structure. So if we go into the folders, then we have source, all tenants, Azure AD, and for example, AAD groups. And it has an item and the test group 100. That's it. So let's see if we can find the same in our hash table. It is 1. Yeah, that's the problem. PowerShell doesn't like these kind of keys with a dash in it, so we have to use quotes. Here we go. So we have the next level, like Azure AD, Base, Exchange, and so on, pure view. So we go to Azure AD. And then here we have all the workloads that we want to configure, like administrative units and so on. So let's get to the AAD groups. AC, AAD groups. And there are items, as defined in here, right, the top. And there is my group, right? So we have just one huge hash table that contains all the information read through the YAML files. And getting to the datum YAML, don't forget that. And here in the datum YAML is defined what are the containers, what are the paths that we are interested in, right? First of all, we define the paths. And then we have our hierarchy. So you remember the pyramid that defines how many layers we have and how these layers are interacting with each other. This is defined in the resolution precedence, and the merging behaviors are down here. I don't want to get into details. It's something that is a little bit complex. But as this workshop is on GitHub, it serves as a template, and they can easily start from there. Florian. Pardon? Come on again. The question is if it is sorting the data.
You said registry and another location more registry. Then does it sort, and then it happened after the config.
Okay, so the question is, I think, not about sorting, it's about merging, is it? Yes, it does. So if we, let me rephrase the question, maybe I got it wrong. So if we have registry key, or let's say AAD groups defined on multiple layers, right? So who wins? Is that the question? Which is the final data that I receive?
Yeah.
Okay.
If you have the same thing in different locations, then
exactly. So if you create conflicts, actually, if we are creating conflicts, I think then we're having merge issues. Then we are getting an error. If you are not creating conflicts, but if you are defining, let's say, groups on multiple layers, then it's up to you to define what should happen to the data. Usually, the last write or the highest hierarchy wins. So here we have the default lookup option, which is most specific. Most specific means the highest layer. The highest layer always wins. But if you want to be able to define some certain type of data on multiple layers and get this merged together, then you can specify lookup options and define a different merge type. So for groups, we have the merge type deep, which means we are taking the hash tables, which are defining groups on all the layers, and put them together into one large list, right? So if you define registry keys on multiple area or multiple levels, then they would be merged as well, right? So in this case, we want to be able to merge all the groups together, and the key is the mail nickname, because this one is unique, right? So if there are two identical mail nicknames, then actually, do we get an error, Gail? Do we get an error if we have two nicknames, two identical nicknames? Pardon? Yeah, I know, but what happens if the mail nickname is being defined twice on two locations? Merge it together. Okay, but then the question is, okay, if we have the same object with the same mail nickname but different data, what's happening then? Okay. I guess so, right. Yeah, the DSC compilation will fail. Yeah. Okay, and to kind of answer this question in a bit more a bit deeper way, we have the concept here of RSOP. I think this is a term known in the group policy world. So the thing is, if someone wants to know what's the configuration of my tenant, then going manually through all these files is pretty difficult, right? So you need to have some way of getting an overview. And this is done in the build process as a parallel step, and it's creating these RSOP files. And the RSOP files are containing really all the settings in one huge YAML file. So this is then the result of the merging process. And if you are not sure where a certain setting was coming from, we have also added RSOP with source. And then you see at the end of the table exactly the layer where we are getting the data from. Right? So this is very helpful if you are troubleshooting data, or if you're troubleshooting some merging issue and have no clue where the data is actually coming from. And the process behind that is, I hope I can demonstrate that. So we do then a get datum RSOP. The datum structure, all nodes is, I guess it works like this. No, it does not. I need to specify a node, which is all nodes def LCM. Yeah, and here it works. So that was the line. Give me the full view from the datum, from that datum variable, and for that specific node. Right? As mentioned, we don't deal with nodes. We have to deal somehow with nodes, with computers, because DSC was mainly made for on-prem scenarios. But in this case, it's only for reaching out or getting the configuration of that particular build worker, which is then reaching out to Azure again. Right? And then here we have the full-blown view, all the groups. And let's have a look at the groups. $R for RSOP, $R dot CAD groups dot items, and we have a bunch of test groups, 1, 2, 3, 500, 100, and let's search for 100 in our project, and we see this one is defined all tenants, and another time on our production specific. What do we do here? Are we disabling it here? No, so we have defined it multiple times. No merge conflict, because obviously it was exactly the same object, so then it works. Otherwise, we would get into trouble, right? Yeah, but this is the command that finally creates the specific view for that particular node, which is then applied by DSC. Good. Let's see what happened to our build so far. Yeah, still running. But we have went pretty far. So we are currently validating our production environment, which means that we have, I guess, removed something. Let's go into our log. Raw log. So what did we do? We removed test group 1. There it is. And what we can see here, hopefully, is we are testing if test group 1 is in the desired state. That's very verbose. And obviously, it was not in the desired state, and therefore we are going into the set method, right? And if we go down, it only happens, hopefully it only happens to that one. What is about test group 2? Test method, skip set, as expected, right? So we should see a lot of skip sets because the configuration hasn't changed very much. We changed only one specific item. This item was configured and the rest is always skipped. Yeah. Yeah, so I think Datum is the key behind that. First of all, you need a framework that makes the whole process fully fully reliable and automatically and running in a pipeline, right? So most DSC solutions that we've seen, also the white paper that is from M365 DSC community, is not following the best practices that I have learned from Gail, Stephen, and Michael Green. So the nice thing here is you have a kind of solution that is almost ready to run on all the automation projects that we have. One customer is using GitLab for that. Usually we use Azure DevOps. You have a release pipeline that works locally, so it's debuggable, which is also pretty important. It creates all the artifacts without any human intervention and copies the artifacts to the right machines for them to actually invoke the configuration. And we have also automated and enforced testing. So if something goes wrong in the process, then we get feedback immediately. This is also one of the very important things for every DevOps project: fail fast, right? If something goes wrong in the process, you want to know this immediately, as soon as possible, and not after the things have been enrolled into the production environment. So this is why putting energy into automated testing and making sure that your config data is right, that your artifacts have been produced the right way, and that the artifacts could be applied the right way is crucial. Good. Yeah, sorry, this presentation wasn't prepared. It was on a very short notice, and it's a very complex thing. So we worked over the last 1.5 years in this, and it was mainly influenced by what the customers wanted to see and wanted to have in their environments. So we have 5 major customers that like the idea and that we are working with together, and I am pretty sure that this project will grow over the next couple of months to something even better. Right. So if you are interested in that, it's all open source, it's on GitHub, and I hope to transfer it to the DSC community soon. Gail always requires some documentation, which is not ready yet, but we are working on that. Good. Thank you very much.